Hello friends, in today's class we are going to talk about syntax directed definition for construction of abstract syntax tree. Welcome again, and now we are ready for this syntax directed definition for this construction of abstract syntax tree. Okay, so we are ready with this. So this is the typical definition, and here we are having this as production rules. Okay, so this is part is the typical production rule, and this is my semantic rules. Okay, so now so this is the idea of this construction of abstract syntax tree. Okay, so let me just take a example, and let's take the same example: a plus 4 minus c, the same w that I just demonstrated how this will be done. Okay, so the first part is the parse tree, and the parse tree consists of okay, this is not minus. Okay, so this is my string, and a plus 4 minus c, it's my string. So let's draw the parse tree over here. Okay, so e there is a plus. Okay, we don't have minus. Okay, so e plus 4, let's have multiplied by c. Okay, so now we have a plus operator, and now let's have e derive, and it is calling this one as e1, same e, but e1 for naming convention, e1 and t. And then now we have a t derive, t star f, and just for left and right hand side it is calling it as t1. And then now e derives the t, and t derives f, and f derives id. T derive f, f derives id, and f derive. Okay, now this is no id, this one is a number, sorry. So let me just erase it, and this one is number, and I can call it as num, which is having number dot value as 4. F derive id, and that is your id, and that is will be c. Okay, so now look at here: f derive number, f derive id, and in both the cases we have to make leaf, and we have to return fptr to this. Okay, so now this will return f dot ptr, will be holding the address of what? It will be holding the address of this make leaf id dot entry. Okay, so id dot entry will look like this a, and this will point towards symbol table for entry of a, and this pointer I'm calling it as p1, and f1 dot ptr will hold the value of this p1. Similarly, there will be a make leaf num and num dot val. So this is the entry that I'm calling it as num, and value is 4, and this is the pointer, suppose p2, and here f dot ptr, okay, will consist of, let's say, pointer p2. Okay, so now we are done with this leaf part, and let's have one more leaf for this id, and here let me just create one more pointer over here, whatever the pointer, let me call it as right now p3, and here id, and this will be a pointer symbol table to pointing to c. So now here f dot ptr is p2, and here I'm writing f dot ptr is equal to p3. Okay, T2f and T dot PTR will be T dot PTR will be equal to P1, and E to T, E dot PTR will be equal to here again P1. So this is a chain that is working from here to here. Okay, now here T2f T dot PTR will be equal to here P2, and here F dot PTR is equal to P3. Now T star F, T star F, what does it say? That make node, so we'll make a node over here. So this is my node. Okay, and that node will consist of a star and t1 dot ptr. So t1 dot ptr is what? P2. So this will point here. Okay, this will point here, and this one E and F dot PTR. So F dot PTR is 3, so this will point to here. Now finally we are and then that value will be stored in T dot PTR. Okay, so T dot PTR, this is the node, and let me call it as P4. Okay, so T dot PTR will be equal to what we have assigned, P4. This node is P4. Finally here we are here, and we have to make node plus, so I'll create another node over here that is a plus, and E1.ptr, which is equal to P2, so this is pointing here, E1.ptr, and T.ptr will consist of P4, so this will point over here. Okay, so now so we are done with this, so here finally, E.ptr will be, I'll call it, let's say, as a 5. Okay, so E.ptr will be P5, and let's call it as a P5. Okay, so now this is what this is abstract, okay, abstract syntax tree, abstract syntax tree. And what is this? A condensed form of parts tree. What is condensed form? We'll keep only this important information, roots as operator, leaves as our ID or number, rest will take it out and collapse the chain of single production. Okay, so that is an example of abstract syntax tree. This is one of your IR or intermediate representation. So that's all for this discussion. Thank you.